Hi there, my name is Emmy and I'll be your guide for your first module of Day 4. I'll be talking to you about how to find derivatives of functions. Please pause this presentation at any time when you need more time to think about something. A derivative is concerned with how one quantity changes with respect to another quantity. In other words, it is a rate of change with respect to a certain variable. The derivative of a function y with respect to x will show us how y changes as the value x changes. So it simply gives the slope or gradient of a function at a particular point. If y is a function of x, then the derivative of y with respect to x is represented by the various notations seen here. Please keep in mind to use these notations for the derivatives. The process of finding the derivative is called differentiation. Differentiating a linear function is to simply find the gradient or slope of that function. Recall you learned about gradients of linear functions in Day 2. For example, the linear function 3x minus 2 has a gradient of 3. So the derivative of this function is 3. Now consider differentiating a function that is a constant value of 9. The derivative is 0 as there is no change in the value of y. If we have y equals to 4 minus 5x, the derivative of y with respect to x is simply equal to the slope of y, which is minus 5. The graph of a quadratic function is a parabola. This means that the gradient is changing as x changes, and we cannot calculate the derivative as we did for the linear functions. The slope of a function at a particular point is the slope of the tangent to the curve at that point. So to find the derivative of a function, consider the gradient of the tangent to the curve at a certain point. Let's consider the curve y equals to x squared. First, take an arbitrary point xy that is on the curve. The corresponding y value will be x squared. Then take another point on the curve with the x-coordinate as x plus h. Its corresponding y-coordinate is the square of x plus h. Then draw a line through these 2 points. Now to find the gradient of this line, this is simply given as changing y over changing x. That is the difference between y-coordinates of the 2 points over the difference between the x-coordinates of the 2 points. This will simplify to 2x plus h. So the gradient of the line through the 2 points is equal to 2x plus h. However, this is not the gradient of the tangent. To find the gradient of the tangent, we need another step. Notice that as h became smaller, the line through the 2 points, that is a black line, became closer to the tangent, shown here as a red line. As the value of h approaches 0, the gradient of the line through the 2 points approaches the gradient of tangent to the curve. As h approaches 0, we find that 2x plus h approaches 2x. Hence the gradient of tangent to y equals to x squared at a point xy is 2x. This method is called the differentiation by first principles. In general, the derivative of a function can be given by this limit if it exists. It is not a method that we have to repeat for every differentiation. We use this method to find the derivative of functions, and thereafter we can simply reuse the results without going through the whole process from scratch again. Here is a summary of the differentiation by first principles for y equals to x squared. Pause this presentation to study it. Again, you do not need to use a differentiation by first principles every time you differentiate. You can simply use the results. In this slide, we'll present some rules of differentiation that you can commit to memory to make differentiation easier. Recall that the differentiation of a constant, that is, there is no change in the y value, is 0. The differentiation of x is 1. The differentiation of x squared, as we have shown before, is 2x. the differentiation of a function multiplied by a constant is the same as the differentiation of the function and then multiplying the result of that differentiation by that constant. When differentiating a function plus another function, this is the same as the sum of the derivatives of each functions. This means that you can differentiate term by term. For example, let's differentiate y equals to 5x squared plus 3x minus 4. Here we can differentiate one term at a time. Now for 5x squared, we can take out 5, which is a constant, and we know the differentiation of x squared is 2x. So the differentiation of 5x squared is 2x times 5. That is 10x. Similarly, for 3x, we can take the 3 out, and we know the differentiation of x is equal to 1. So the differentiation of 3x is 3. And 4 is just a constant, so its differentiation is equal to 0. Putting it all together, the derivative of y with respect to x is 10x plus 3. Let's have a look at another example. Differentiate the function f equals to 2 minus 4x minus x squared. Again, we differentiate each term separately. The differentiation of 2 is equal to 0. The differentiation of 4x is equal to 4. The differentiation of x squared is 2x. Hence, the answer is minus 4 minus 2x. Here are some practice questions for you to do. Press pause to attempt them and press play to see the answers. Here are the answers.